Hello, my name is Shannon Lawless, and I'm a Presidential Honors Student at Tarleton State University. For my research project this last year, I was analyzing the different land cover change of different lakes, and that's what I will be presenting to you today. Lakes across the world offer an abundance of resources from animals, humans, and economic growth. It is important to understand how they are changing and any trends in order to help preserve this precious resource and ensure that they are being used appropriately. The purpose of this study is to analyze the land cover change of different lakes in Texas. The sites with the most significant changes will then be further analyzed based on the ecoregion they are in to see if there are any trends between what the land is used for. This slide shows the NLA sites with the Texas ecoregions they are classified under. These are the specific sites that have been analyzed in this research study. First, I would like to discuss how the analysis was done. TCEQ gave us buffer data around all the NLA sites shown on the previous slide. There were 3 total buffers around the lake, including a 200, 500, and 1,000 meter buffer. This slide shows an example of the buffer zones being used to compare the land use analysis. First, a few box plots were made in order to begin comparing the data. On this slide, these are some examples of the box plots that were done initially. The top one is the percent land classified as water in 2001, and the bottom is the percent land classified as water in 2006. These maps were used just as a way to glimpse the change generally. For example, the West Gulf coastal plain ecoregions, the percent water decreased over the years. These plots were not selected as the main source of analysis, however, because the data that was given could not be clearly represented on these graphs. This next box plot shows the difference between the land cover from 2001 to 2006. This particular graph shows the percent change of land classified as water. As you can see, the Southwestern Tablelands showed the largest change, with the most of it increasing. These graphs, again, were not selected as the main source of analysis because the origins and values are difficult to interpret. Based on this understanding, more of the analysis occurred using a tabular format of the data instead. This is an example of the tabular format that was used. The data given by TCEQ was formatted into Excel as shown in this subsection, which again represents the percent change in land area for forest cover from 2001 to 2006. It was then decided that only sites with significant changes would be analyzed as important, and this was determined to be any site with a percent change of 5% or higher in either direction. For example, in this subset, only the 3rd site shown had a significant change in percent forest coverage. Based on the methodology mentioned above, an analysis of each site with the significant change was done. This slide shows the sites that were determined to be significant. There were only a total of 9 sites that had significant land cover change, and they will be analyzed further in the next few slides as well. First, the 3 sites that were found in the West Gulf coastal plain ecoregion were analyzed. None of these sites showed significant changes for land classified as barren, forest, shrubland, or herbaceous cover, which was surprising as the ecoregion is comprised of forest and woodlands. However, the sites chosen are mostly within the city landscapes and not the country areas, so this could explain why that's the case. Both sites 118 and 161 showed a high decrease in the planted and cultivated land classification, and for both sites the farmland was converted to developed area. Site 129 also had a large increase in developed area, but this came from a decrease in wetland classification. Most of the change for sites 118 and 161 occurred further from the lake boundary, while the change for site 129 occurred near the lake boundary. Next, the 2 sites located in the South Central Plains were analyzed. Again, neither of these sites showed significant change in developed, barren, forest, shrubland, or herbaceous land cover. The amount of land cover classified as water decreased for both sites. The water land cover for Site 113 was converted into wetlands classification, and for Site 169, it was converted into farmland. For both of these sites, this change happened closer to the lake boundary. There is only one site to be analyzed in the Texas Blackland Prairie ecoregion, and it did not show a significant change in water, barren, forest, shrubland, herbaceous, or wetland cover types. Most of the change for this site occurred further from the lake boundary, where the developed land cover increased and farmland decreased, similar to the sites seen before, sites 161 and 118 in the western Gulf Coastal Plain ecoregion. Again, the Cross Timbers ecoregion also only had one site, and it did not show significant change in barren, herbaceous farmland or wetland cover types. The water, forest, and shrubland cover areas for this area were all decreased near the lake boundary, and then were converted to developed area. The reason why it was so many that were decreasing is because the developed area for this particular site actually increased a large 40%, which was higher than any of the other sites that we saw. The Southwestern Tablelands ecoregion had two different sites. They were located pretty far apart from each other, which is why there's two different maps shown. Neither of the sites showed a significant change in barren, forest, or farmland cover types. For Site 103, both the water and shrubland cover decreased closer to the boundary, which were then converted to developed land cover area. Site 152, however, showed a decrease in shrubland and herbaceous land cover over the entire buffer of the lake, which was then converted to water. As seen in the analysis section, almost all of the 9 sites, 6 out of 9 to be exact, saw an increase in developed area. This was expected to be one of the highest areas of increase at the beginning of our study, simply because new development in Texas is growing and expanding every single day. In most cases, the land that decreased in this area was farmland. However, one saw a decrease in shrubland and another a decrease in wetlands. The wetlands decreased particularly surprised me because of how protected these areas are. However, there could be many implications to this decrease, such as needing to stabilize the lake boundary for some reason. Of the other 3 sites, 2 of them came from the South Central Plains. These were actually all of the sites with large cover changes in this ecoregion, neither of which involved developed area. One of the sites simply had a change from water to wetlands, which could have been caused by reclassification of the terms or a long period of drought, and the other site saw a change from water to farmland. The increase in farmland makes sense because the ecoregion is largely used for farming and the soil is very good for crop productivity. The decrease in water, again, could have been due to several things, including the formation of a dam or a decrease in the water line. The last site that saw change was different, was in the Southwestern Tablelands ecoregion, and it saw land classified as herbaceous cover change to water. This could have been due to flooding, a rise in water boundary, or the numbers may have been calculated during a very wet season for that area. Overall, the largest increase by far occurred from developed area, with largely decreasing farmland in general. As the population in our world continues to grow, specifically in Texas, which saw an increase of almost 400,000 people in the last year alone, according to the Census Bureau, the fight for space always continues. Understanding how these changes are occurring, especially near precious commodities such as water, is an important step to trying to keep the balance between all the different land uses that are necessary. Finally, I would like to acknowledge specifically Dr. Kartik Venkataraman, who oversaw this project. The data that was used is from the EPA National Lakes Assessment 2012 Technical Report. Other acknowledgements are for TCEQ, which awarded the original research grant to Tarleton and Tier. My assisting on this original research is what introduced me to the data and gave me the idea for this research project. I thank you guys very much for your time and hope you have a wonderful day.